The Honda K20 is a legend. Right out of the factory, it flows air incredibly efficiently, making it a highly responsive, naturally aspirated engine. But that responsiveness creates a trap. Because the engine reacts so well to modifications, it gives off the illusion that massive horsepower is cheap and easy to grab. You might be tempted to spend your entire budget on shiny intake and exhaust pipes, completely ignoring the invisible software actually needed to run them safely. This single decision splits your build into two completely different paths. If you bolt on an intake and exhaust but skip the engine control unit, you drastically change the air-to-fuel ratio. Without digital instructions to add more fuel, the engine runs dangerously lean. That extreme heat and lack of fuel leads straight to a blown motor. On the flip side, if you buy a programmable ECU first, install those exact same bolt-ons, and get a custom tune, you safely unlock 30 to 50 horsepower. Building a Honda K20 requires strict sequencing. Skipping the digital management to save a few bucks up front guarantees you will destroy your physical hardware down the road. Before touching the inside of the block, we start with Phase 1, the foundation. Your only objective here is to let the engine breathe by optimizing air going in and exhaust gas going out. For the intake, you need a 3 or 3.5 inch cold air setup. The K20 loves dense air. If you bolt on a generic short ram intake, it will just suck up hot engine bay heat and actually cost you power. To get the exhaust out, ditch the restrictive factory manifold for a high-quality long-tube 421 race header. Pair that with a free-flowing 2.5 or 3 inch exhaust to unlock massive mid-range power. If you have an older K20, you can drastically increase incoming air volume by grabbing a Honda RBC intake manifold off a 2006 to 2011 Civic Si and pairing it with a larger 70mm throttle body. But here is the golden rule of K-Series tuning. You have to purchase a programmable engine control unit before you turn a single wrench. Systems like Honda K-Pro or K-Tuner act as a mandatory tax. It's a steep $700 upfront cost that adds zero visual flair to your engine bay. Those high-quality physical airflow parts are functionally useless and actively dangerous without the digital mapping required to correct the massive changes in the air-to-fuel ratio. Adding that power instantly exposes the weak links surrounding the engine. The moment you push past basic bolt-ons, especially if you introduce E85 fuel or aggressive camshafts, the factory fuel system cannot keep up with the demand. You correct this by upgrading to 1000cc or larger fuel injectors and a high-flow pump, like a Walbro 255 or 450. Then there's the drivetrain. The factory K20 clutch will instantly slip once you cross roughly 220 wheel torque. You'll need a Stage 2 or Stage 4 clutch, depending on your final power target. Under heavy load, the K-Series block rotates aggressively, which physically twists the engine and throws the chassis out of balance. Swapping in stiffer polyurethane motor mounts locks the block in place, keeping the transmission aligned so you don't miss gears during those 8,000 RPM shifts. The trade-off is comfort. Those stiff mounts solve the performance issue, but will send heavy vibration and harshness straight into the cabin while you commute. You have to budget heavily for this infrastructure, deliberately trading daily comfort for structural integrity before you can safely use advanced engine power. If you want to keep the engine naturally aspirated, but crave that classic high RPM screaming Honda power delivery, we move to Phase 2. The primary internal upgrade is dropping in aftermarket Stage 2 camshafts. These alter the valve timing, forcing the engine to pull hard all the way past 8,500 RPM. To survive those engine speeds, you absolutely must install upgraded valve springs and titanium retainers to prevent valve float and catastrophic internal damage. There is a popular alternative to building the internal K20 block. It's called the K24 bottom end trick. You take your high-flowing K20 cylinder head and bolt it directly onto a larger 2.4-liter K24 engine block, usually pulled from a CRV or an Acura TSX. This hybrid setup marries the screaming high RPM airflow of the K20 head with the massive low-end torque provided by the 2.4-liter block. Achieving extreme naturally aspirated power requires meticulous component matching. You trade the simplicity of bolt-on parts for complex, precise mechanical surgery. If your goal is anything over 300 wheel horsepower, you have maxed out natural aspiration. You need forced induction. The factory K20 internal components are exceptionally stout. On a perfect tune, the stock pistons and rods will reliably handle 400 to 450 horsepower. This matrix compares forced induction options. Turbos offer highest peak power, hitting 400 to 700 horsepower for drag racing, but require custom plumbing and introduce turbo lag. Superchargers provide instant throttle response, ideal for autocross, despite lower peak horsepower and constant belt stress. Forced induction maximizes the platform's capability, but it forces a strict compromise. You have to choose between absolute peak straight-line speeds and predictable corner-exit drivability. This quadrant maps your build. Novice daily drivers prioritize Phase 1 bolt-ons and an ECU for reliable horsepower. Track optimizers add stiff mounts and a supercharger for linear power. Max power builders skip naturally aspirated internals, upgrading fuel, clutches, and adding a turbocharger. Whichever path you choose, the absolute core rule remains. Never purchase an airflow modification without securing the software to manage it. Power must always be matched by infrastructure. Never add horsepower without upgrading the fuel system and mounts to support the physical load. The Honda K20 heavily rewards patience and planning. If you modify it sequentially, it will deliver reliable, high-level performance for a lifetime.